Welcome guys, back again to another video. So this is our photochemistry video series. If you have not watched our previous videos, which we have talked about the basics of photochemistry, right? And then Joule diagram, quenching, fluorescence, likewise we have talked much more interesting topics, right? So you can watch it out in our playlist. And now today in this video we are going to talk about the sensitizers, right? We have talked about the quencher molecules and quenching in our previous video, right? So this sensitizers, sorry about my pronunciation, sensitizers are same like the quencher molecules. The function is basically the same, but there's a little bit difference than the quenchers, right? In quencher, if you remember, right, we told you that the quenchers are more efficient in interacting with the triplet state, right? So basically we call them as triplet quenchers, because like they interacted more with triplet state molecules. So when you have a triplet quencher, the excited triplet state will quickly go back into our ground state. So in your mixture you don't have a triplet state, because every molecule which is in triplet state will come down to the ground state using a triplet quencher. Now when it comes to sensitizers, right, the opposite will happen, right? In this case you only have the triplet state, right? You only have the triplet state. The singlet state will come down to the ground state. So in your mixture you don't have a singlet state, but you have a triplet state. In the quenching you don't have a triplet state, you only have a singlet state. Let's see how these sensitizers are working, right, in our reaction mixture. Let me erase this. Okay, now sensitizers are most like ketones, okay, the molecules with like carbonyl groups. Those are sensitizers most of the cases. Now when you have a sensitizer, okay, in the ground state, they can be irradiated using the UV visible light. So here they have excited into the singlet state, because this is the most allowed transition. And then the most important thing in the sensitizers are they are very efficient in inter-system crossing. If you remember what the inter-system crossing is, right, you know there are excited state. S0 means the ground state. Here you have the singlet excited state, and there is the triplet excited state. Transition from here to here is forbidden, because delta S is not 0 when it comes to the transition between S0 to T1. You remember in spectroscopic knowledge, for a allowed transition delta S must be 0. So these are forbidden transitions. So practically you will observe very less amount of transitions like this. But there is a possibility to transition from S1 to T1, which we call as inter-system crossing, right? So in sensitizers, right, this process is very efficient. So these will come to the T1 state, okay, T1 state. Now what happens is you have your molecule in the ground state, okay, and also you have the sensitizers which are in triplet state. So these two can interact and form sensitizers in the ground state, and our molecules in the triplet excited state. So you can see in the presence of a sensitizers you will get a very minimum amount of singlet excited state, because most of our molecules will be irradiated into the triplet state with the help of a sensitizer. But when it comes to quenching, right, the quencher molecule will efficiently react with the triplet state. So you don't have a triplet state in your mixture, you only have the singlet state. In this case you only have the triplet state. That's the difference. So if your reaction needs the triplet state, you need to think about what intermediate or what molecules you should use, whether it's a triplet quencher or sensitizers, right? I hope you get the idea about these sensitizers, right? So I hope you know why we can't use the singlet quenchers. basically like we have talked about this particular thing in our previous quenching video, right? I will I will recall it again for you. So like quenching, when it comes to quenching, you need the interaction between the two between the excited state and your quencher molecule. Singlet excited state has a relatively low lifetime, so this lifetime is not enough to interact with this quencher molecule. So this singlet excited state, right, the quenching with the singlet excited state is not efficient, but triplet excited state is relatively very efficient in quenching. That's why we are considering the triplet quenching, right? Triplet quenching when to isolate the singlet state, and sensitizers, right, sensitizers when to isolate the triplet excited state. I hope you get the idea. So this is a very straightforward video and straightforward concept. Only thing is you just need a clear note and very clear diagram to explain it to you, right? So I hope you get the idea, you get the concept. If you have any problem, please feel free to comment below. I will try my best to answer your questions.